In this video, we're going to continue taking a look at limits. And here we are going to look at an example where we are asked to numerically estimate the limit. Now, keyword here is the word numerically. That is going to tell us we should create a table. We're going to use a calculator, create a table of values to do this. What is our value of x heading towards, right? So we have the limit of x over x plus 4 minus 2 as x approaches 0. Right? So we have our x value is getting closer and closer to 0. So when we go and plug in values, we want to plug in values that are getting closer and closer to 0. So let's create a table here. We'll have our x values. We'll have our function values. We will pick values that are smaller than 0. Right? If we were to throw 0 in itself, we would get a 0 in that denominator, and that would be bad news. So let's see what happens when we have a value that is like 0.1 to the left of 0. And then we will get a little bit closer. We'll just go 0.01 to the left of 0. And then 0.001. And then we'll do the same thing to the right of 0. 0.1 to the right. 0.01 to the right. So we'll pick values on both sides and see what happens. And so if we were to plug in negative 0.01, we plug that into this function, right? We replace every single value of x here with negative 0.1. Then we would get something like 3.975. If we plug in negative 0.01, we'll get something like 3.997. And then we would get 3.999 if we go negative 0.00. If we start with values to the right, and we start way out here at 0.1, we plug 0.1 into that function. You might want to take the time to plug that in yourself, or at least verify that you will get these same values. Make sure that you understand how to plug the numbers into your calculator and work your calculator appropriately. But we can plug 0.1 in. When we plug 0.1 into this function, we get something like 4.024. Take a value that's a little bit closer. We will get 4.002. And if we go closer still, we'll get 4.0002. So what appears to be happening to our function value f of x as we approach from values of x to the left of 0? Well, it looks like it's going 3.975, 3.997, 3.999. It looks like it's approaching 4. And if we have values of x that are to the right of 0, our function f of x, it looks like it's heading to 4 from this side as well. So whether we start with values of x to the left or to the right, our function appears to be settling in on 4 from either direction. So that's what we're looking at. So that was a numerical estimate of a limit. Let's take a look at another example. Here we are asked to graphically estimate a limit. So we consider this piecewise defined function. We want to graphically estimate the limit as x approaches 2 of f of x. Right? So graphically, so we're going to use the picture. Now we're not provided a picture, so we're going to have to draw that picture. But we want to use that picture to try to decide the value of this limit. Now, what limit are we looking at? We're looking at the limit as x approaches 2. And so let's draw this graph. Right? So here, this graph is x plus 1 as long as our x values are less than 2. So when our x values are less than 2, our graph looks like this. When our x value is 2 itself, so if x is equal to 2, then our y value, the function value, should be 5. So at 2 itself, this is defined to be 5. And for x values that are larger than 2, we have x squared minus 1. That x squared minus 1 ends up looking like a parabola. It kind of looks like this. So when we look at this limit, when we think about this limit here, we have a limit as x approaches 2 of f of x. We are asking ourselves, as we get closer and closer to 2 from the left-hand side, what is our function heading towards? Well, it looks like it's getting closer and closer to 3, right? When you plug in values here, or in the picture, if we're not at 2 itself, we're just really close to 2, then we're getting our function value is approaching 3. If we are a little bit larger than 2, but we're getting closer to 2, then our function value here also appears to be approaching 3. So this limit, the limit as x approaches 2 of f of x, it is equal to 3. And that's a little bit strange because the function value at 2 itself is not 3. Right? So our function value at 2 is actually equal to 5. Way up here is the actual function value at 2. But if we're not quite to 2, we're just really, really close to 2, then we're approaching this value of 3 right here. So those are 2 more examples, one where we numerically estimated a limit and one where we graphically estimated a limit. In our next video, we will look at some more examples. We will see you there.